All right, welcome back. In this video, we're looking at another situation where we're taking a graph and revolving it about a axis other than the x or y axis. So here we're looking at cosine, 2 cosine x, just in the interval 0 to pi over 2. So, in other words, along the x-axis from 0 to pi over 2. All right, so that's what we're dealing with right there, is that shape there. Except now we're revolving it about the y-axis, or the y equals -1 axis. So once again, we see that it's touching it. So all we have to do is come up with our radius. How far is it from the graph to our axis? So we can just draw in a little sample rectangle here and see that the gap here is going to be the gap of 2 cosine x, and then add on this extra gap of 1. So here we recognize our radius as r equals 2 cosine x plus 1. R equals 2 cosine x plus 1. Okay, so that's our radius, and then it's just touching it, so again we're just doing disk. We're just going to be dealing with disk. Okay, and so let's set about doing that now. So we would have the integral from 0 to pi over 2 of pi times the radius squared. 2 cosine x plus 1 quantity squared dx. All right, and then we need to work this integral out. Well, that's going to take a little bit of time. Here. This is one that setting it up's easy. Working this integral out is going to take a bit of time. So of course we can pull the pi out front, 0 to pi over 2, and then we need to square this. So that'll be 4 cosine squared plus 4 cosine x plus 1, and again that'll all be evaluated between 0 and pi over 2. Now, to work this integral out, we're going to have to deal with the 4 cosine squared. And this is something that I believe we ran into earlier when we were dealing with the volume underneath the sine x function. All right, so we need this result right here, this trig identity. Cosine squared x is 1 plus cosine of the double angle all over 2. And so we're going to have to use that result here. Again, that's the only way we can deal with integrals with cosine squared, is by using that result. It's actually another way we're going to get to eventually, but for now, that's what we have. So the 4 cosine squared is going to become 4 times 1 plus cosine 2x over 2. So that'll actually be 2 times 1 plus cosine 2x. And then plus 4 cosine x plus 1 dx. And that'll all be in the integral 0 to pi over 2 with the pi out front. So when we simplify this, we're going to have pi times the integral 0 to pi over 2 of, first of all, 2, actually, yeah, I'm going to do it this way now. I'm going to break it up into separate integrals because of my substitution needs for the cosine 2x. So I'm going to have a 2 times the 1 plus the 1. That'll be integral of 3 dx plus 4 pi integral 0 to pi over 2 of just cosine x plus pi integral 0 to pi over 2 of cosine 2x times 2 dx. So I'm taking the 2 that's out front, I put it with the 1, add it to the 1, you got 3. And then I have a 2 with cosine 2x, but I'm going to need the 2 dx. So the substitution will go through because you use 2x. dx would be 2 dx, so I need that to carry the substitution through. So when I work that out, I will have pi on the outside, 3x. Integral of cosine is sine, and that's going to have the 4 with it. So that's just going to be 4 sine x. And then finally, cosine set up and ready to go through. So that's going to be just plus sine of 2x. And this is all going to be evaluated between 0 and pi over 2. Okay. So then we just start to compute that. Plug in pi over 2. So pi on the outside, I'm going to have 3 pi over 2. When I plug in 0, plug in pi over 2, sorry, I'm going to have sine of pi over 2, which would be 1. So 4 times 1. And when I plug in 2x, 2 times pi over 2 will be pi. Sine of pi is 0. All right, so that's that part. And then when I plug in 0, 0 and 3x will be 0. Sine of 0 will be 0. Sine of twice 0 will be 0, so that's all going to be 0. So I'm actually going to get this weird looking answer. Pi times 3 pi over 2 plus 4. Okay. Cubic units. Yeah, so kind of a really weird, ugly result there at the end. But that's the kind of stuff that we do sometimes get.